Hello. Now we'll do this problem where we are dealing with a rigid body. So this is my rod, which is a rigid body. Its mass is given m and the length of the rod is L. So this rod is hinged at this point. I'm calling this point as A. It is one of the corner of the rod. So at this point, this rod is hinged. You must know that what it means by the hinge. Hinge means if there is a rod and we fix this rod with the help of a screw with some fixed wall. So this rod, since it is hinged along this axis, this rod is hinged along this axis, so there can be movement of the rod around the hinge. This kind of movement is possible, but it cannot move in this direction. So if this is a rod and this is the direction of hinge, this rod can rotate like that. But this rod cannot move like this one. Okay. So this rod is hinged at this point, and the other end of the rod is connected by a thread, and this thread is hanging. It is fixed from here. There must be some tension in the thread, obviously. It is holding to this rod. So now, this rod is not moving, this rod is balanced. So if this rod is balanced, till now we used to say if some system is balanced state, in that case all the forces which used to act onto the system, they used to be 0. Net force of summation of all the forces used to be 0. So in this case, net force is 0. But along with that, since this is a rigid body, it's not a point mass, in this case, it's not just that motion of a one point is not happening. It's just all the motion, all the points, they are not moving at all. So in that case, its net force acting onto this rod has to be 0. Along with that, the net torque acting onto this rod also has to be 0 about each and every point. So if there is a rigid body which is at rest, in that case, the force, net force, as well as the net torque acting onto the body has to be 0 because there is no point which is moving. So it means the movement of force about any point has to be 0. Okay. So we know how to calculate. Like first of all, let's count the forces here. If the force is 0, if the net force is 0, and if the net torque is 0, and we know the torque also we used to calculate using the force. So first of all, we need to remember, we need to know how many forces are acting here. So when we calculate the number of forces acting onto the rod, we follow the contact force, we follow the field force first, and then we count the contact forces depending upon the number of contacts. So if you see here, there is one field force which is acting, and that field force is the mg. So the gravitational attraction force due to the earth obviously will be acting at the center of mass of the rod. That's one force. This is a field force. And obviously there is no electrostatic such force and other forces. There is no field force. Now we will go for the contact forces. This is my rod. To count the contact forces, first we have to count the contacts with the other bodies. So this rod is in contact with 2 points. Like point A is in contact with a wall, and this point B is connected with a thread. So this thread, the force is applied by the thread, we know. The forces applied by the thread are along the thread. So this tension T is acting at the point B. This tension T is within the thread, as well as this tension T becomes the external force for this rod acting at point B. Now this point A, if you look at point A, the force at the point A will be the reaction force, and this force is acting at a single point. Since this force is acting at a single point, it's very difficult to calculate the direction of that force. Okay, so in that case, what we do, the contact force, this reaction force, we divide the reaction force in 2 components. So if you remember, whenever there is a force for which the direction is not known, what we do, we divide that force into 2 components. So what we will do, this reaction force, I'm calling this reaction force as N. I'll divide this reaction force into 2 components. One I'll call as Nx, and other I call as Ny. And if you can see, very specific directions I have taken for these 2 components. Direction of one force I have taken along the length of the rod, and the direction of other force I have taken along the perpendicular of the rod. So if I calculate Nx and Ny separately, in that case, by taking the resultant of these 2, I can calculate the reaction force. So there are some total of 3 forces here. One is the field force, and that is mg. Second force is there are 2 contact forces. One is because of tension. So one contact force is tension and other second contact force is Nx and Ny. I am dividing the second contact force as two components, Nx and Ny. Okay. So here, I have to learn how to calculate the torque corresponding to each and every point. So the thing is, this rod is at rest. This rod is not moving at all. So all the forces acting onto the rod has to be balanced. So if you go by that, logic, in that case, net force acting onto the rod in each and every direction has to be 0. So if we go by that, there can be two directions. One is parallel to the rod and second is perpendicular to the rod. So if we balance the forces, upon balancing the forces perpendicular to the rod. So let's balance force perpendicular to rod. So if we do that, we'll make the FBD obviously, and we'll consider only the forces which are perpendicular to the rod. So there are total 3 forces which are perpendicular to the rod out of the 4. Mg, Ny and T. We'll show them. So T is acting upward, Ny is acting upward, and the Mg is acting downward. And under the influence of all these forces, the rod is not moving. Center of mass of the rod is not moving, so I'll say acceleration is still 0. So from here, I'll be getting an equation, and that equation is T plus Ny is equals to Mg. This is my equation 1. So I got a relationship between the tension and Ny. But still, if you can see, there are total 3 unknowns, Nx, Ny, and the T. To calculate these 3 unknowns, I'll be needing 3 equations. So first equation is balancing of the force perpendicular to the rod. I did that. Now what we will do, we'll balance the forces, but this time parallel to the rod. So we'll balance the forces parallel to rod. If we'll balance the forces parallel to the rod, we have to count the forces. And obviously, if you can see, there is only one force, and that is Nx. There is no other force parallel to the rod. So acceleration is 0 because this rod is not moving. So based upon that, in this state, I can say this Nx is 0. So this is the first force. The Nx we have calculated. In this case, Nx will be 0. In some other cases, Nx might not be 0. So you should not make it a rule. It's not a rule that Nx will always be 0. Whenever you are attempting a question where the hinge is there, you have to consider 2 reaction forces, or I should say 2 components of the one reaction force. You always have to consider those forces. And then we calculate. So in this case, in this particular case, Nx we have calculated, and that came out to be 0. So this was my second equation. So second equation I got, but still we had 3 unknowns. Out of the 3 unknowns, 2 are still unknown. One we got from the second equation, but 2 unknowns are still unknowns. So to calculate one more equation, we will need some other relationship, and that relationship we get from torque relation. So in that case, since this rigid body, each and every point onto this rigid body is at rest. So movement of each and every force acting onto the whole body about any point has to be 0. Only in that case, all the points will be at rest. So there is a question of single point. If there is a single point in my system, and if that single point is at rest, in that case, we can just say the net force acting onto that point is 0. That's Newton's law. But if you find a system where the number of points are there, multiple points are there, there is a combination of multiple points, and each and every point is at rest. So we have 2 ways. One way, apply the Newton's law for each and every point. And if you can count, there are infinite points here. It's a rigid body. So one thing is to apply the Newton's law for each and every available point. Or the second method is you apply the Newton's law for the center of mass, assuming that rigid body is not a rigid body, but that's a point mass placed at the center of mass. And each and every force, whether it is acting at each and any point, each and every force is acting only at the center of mass. We convert that rigid body into a point mass, apply the second law. And then after, we calculate the movement of each and every force about any point onto the rod. Any point. The thing is, if you find a question where there are 3 unknowns, 2 equations you will always get by the FPD. If there are 3 unknowns, all you need to do, calculate the torque, select one point. If you find a equation where there are 4 unknowns, what you do? Apply the torque equation about one point, then go for some other point. So depending upon the number of unknown, you will keep applying the torque equation. You will keep balancing the torque onto the rigid body about different points, depending upon the number of unknowns. So here there are 3 unknowns. 2 equations we already got. Only one equation is remaining. So what I'll do, I'll balance the torque. To balance the torque, first I have to select the axis. This axis need not to be the actual axis. It's just a point we select. So while selecting the axis to apply the torque law, one thing we need to remember. Whenever we do calculation, our main objective is that calculation has to be small as possible. Because if you do the lengthy calculation, you will consume time. And any exam you are preparing for, time is a critical aspect. So in this case, I have multiple points. So out of the, directly if you see, there are 3 points which are visible. Center of mass, point A, point B. I can go for any one of the point. The thing is, I'll be selecting the point based upon the calculation aspect. So my calculation has to be small. And if you see, whenever I'll be making an equation, these variables like t, mg, ny, nx, they'll be coming into my equation. So if the unknown variables are less, if I'm making an equation where a number of unknown variables are less, in that case my calculation is going to be fast. So if I select the axis about this point, obviously torque because of tension will be 0. This is t will not be coming into my equation. But that equation will be having ny and it might have nx, though it will not be there, but it might also have that. Okay. If I go for mg, ny will come, nx will come. Obviously mg will not come and t will come. 3 unknown there might be. If I go for a, t will come, mg will come. Mg is a known. There is no problem in that. But nx and ny, they will not be coming. So generally, whenever we select an axis, we always give preference to the physical axis. And if physical axis, because of some reason, I'll not be able to select the physical axis as my axis, I'll go for center of mass. Okay. So in this case, I'll be assuming this as my axis, this A point. So I'll be taking the torque onto the body about point A. So I'll be calculating the torque about point A. Okay. So about point A, if you see, in total there are 4 forces. There is an nx, there is ny, there is mg, and there is t. So if you remember, the formula for torque is tau is r cross f. So this position vector r is nothing but the position vector of the point application of force, where the force is applied with respect to the axis. So if this is my axis, and the application of nx is also this axis. So if the force is applied onto the axis itself, whenever the force is applied onto the axis itself, the moment of that force is going to be 0. So torque about A, if I take, so then that will be torque about A will be equals to torque due to nx. And torque due to nx about A will be 0. Then there will be torque about ny also, torque due to mg also we have to consider, and the torque due to tension we have to consider. So one by one, this nx, since this nx force is applied onto the axis itself, then torque due to this will be 0. This ny also applied onto the axis itself. So torque due to ny will be 0. Now you see mg is not acting onto the axis obviously. So the mg, if you see, this is acting downward. So I have to make a position vector for this point. This is the point of application of force and this is the point of axis. So what I'll do, I'll calculate the r. So if I go for the r, this is going to be the r for this torque. And you see, the angle between this position vector joining point of application of force with respect to axis and the mg, force, is 90. So the angle between these two is 90. Position vector and the force is 90. So if I calculate the torque due to mg, that will be equals to position vector. Position vector is L by 2, magnitude of position vector, multiplied with magnitude of force, multiplied with sine of angle between the position vector and the force, and that is 90 or pi by 2 you can say. Thus, now I will go calculating the torque due to tension. So tension is applied at point B, and the position vector, if you see, that will be equals to this L. And you see, we have to just extend that. And the angle is still 90. So magnitude of position vector multiplied with magnitude of the force, that is T, multiplied with sine of 90. Okay. So these are the magnitude I have written, but the thing is there is this arrow, meaning direction also we have to take into account. And if you remember, when we were dealing with the torque, when we are understanding how to calculate torque, at that time I have taught you a trick. Trick is left hand, you hold the axis, and right hand, you move the force. So if I'm moving the force by holding the axis, assuming this is a rod, So this is a rod, if I'm rotating it, this is a clockwise direction movement which is happening. So the direction of this torque due to mg is clockwise, and clockwise means inward. For me it is inward, for you it will be outward. So since this force, if this force is acting here and there is a rod, if there is a hypothetical rod, obviously there is a rod here. If there is a hypothetical rod, then because of this force, whether the movement of the rod will be clockwise or anti-clockwise. So the movement is going to be clockwise, I am writing that clockwise. And here if you see the tension, its movement is going to be the anti-clockwise, because I am holding the axis, there is a rod. And if I move my hand in the direction of tension, my hand will be moving, or this rod will be moving in anti-clockwise direction. For me anti-clockwise, for you it will be clockwise. So that is going to be the anti-clockwise. Okay, so I am assuming clockwise to be positive and anti-clockwise to be negative for me. So if I do that, then it will be mgl by 2, obviously the sin 90 is 1, and I am taking positive. This one is positive for me. And this becomes negative by default then. So minus of t into L, sin 90 is 0. And that total is 0, because you see system is in balanced state. So net torque acting on it is 0. So if you see this, L and L we can take common and it will go. So the tension becomes mg by 2. So with the help of this third equation, we get the value of tension also. So once we get the value of tension, we have equation 1. By putting the value of tension in equation 1, we can calculate the value of Ny also. Let's put the value. So from equation 1, if you see, if I put the value of tension there, that is mg by 2 plus Ny, that is equals to mg. So the Ny becomes mg by 2. So now you can see, we have calculated the value of Nx, we have calculated the value of tension, and we have calculated the value of Ny. This Ny separately and Nx separately, it is not the reaction force. The combination of these two is the reaction force. Okay, so now you can see whenever there is a rigid body, and if that rigid body is in balanced state, in that case there will be some forces we might not be able to calculate just using the Newton's law. Because Newton's laws are applicable only for single points. And in a rigid body or in a collection of points, there are infinite points. And if you want to apply the Newton's law, you have to apply that for infinite times, which is not physically possible for you. So the extension of that Newton's law we use. That extension is what we do, that rigid body, we convert the rigid body into a point mass and we apply the Newton's law. But that is not sufficient. Then what we do, we calculate the movement of the forces, R cross forces. Movement of the forces about any axis, and we make it 0 if the body system is at rest. And that gives us the other equations which are required. And from there we calculate the whatever unknown value we want to calculate them. Okay. I hope you understand this thing. Okay. Thank you.